to finish up our notes, right, we know that if we have our protons and our neutrons, they equal the mass number. And we know that if we add the protons and the electrons, which are negative, so we can kind of say protons minus electrons, they'll add up to 0 when it's an atom. Well, now we're dealing with an ion. So it says what atoms turn into when they gain or lose electrons, which we know from our PhET simulation, right? We're not going to gain and lose protons. That changes the element. We're going to gain and lose electrons. So to find the charge on an ion, right, you're going to compare the number of protons to the number of electrons. So as an example, find the number of protons and electrons in an atom. So assume it's an atom. So magnesium, right, if it's 12 protons and 12 electrons, if it loses 2 electrons, remember that electrons have a negative charge. That means that you have 12 protons and only 10 electrons, right? So 12 minus 10, or the protons minus the electrons, that gives you a charge of plus 2. So 12 plus negative 10, or 12 minus 10, however you want to think of it, it gives you the charge. Notice where that charge is. You have our symbol of our element, and then in the upper right hand corner is the charge, right? So if you had chlorine and it had a -1 charge, or it might be chlorine with a -1 charge, or it might be chlorine with a -1 charge, right? You might see magnesium. You might see it like that. That's plus 2. Or magnesium 2 plus. Or you might just see something like sodium as just a plus with no number. That means it's a plus 1. Right? So there's all kind of different ways of saying whether it's negative and whether it's positive. Just realize that all of those are the same thing. Okay. Right? So protons minus electrons gives you the charge. So if we're looking at chlorine that has a -1 charge, that means we know that this has more electrons than protons, right? Because electrons are negative. So there's more electrons than protons. There's one more electron than protons. So if chlorine has 17 protons and we want a charge of -1, what number goes in here that's going to make this formula add up to -1? Well, of course, 18, right? 17 minus 18 equals -1. So there we go. There are 18 electrons in this chlorine ion that has a charge of -1. So aluminum plus 3. Remember, electrons are negative. So if this is a positive charge, it has to have more protons than it does electrons. So if aluminum has 13 protons and we need a charge of plus 3, right, it makes sense that there's only 10 electrons, because 13 minus 10 is plus 3, right? So aluminum plus 3, or this aluminum ion, has 13 protons and 10 electrons. Now to find the number of neutrons, you would just do it how you would normally. That doesn't change. Our last one, right, if we are plus 34 and we need a -2 charge, that means we need more negatives than positives. So 34 minus 36 gives us -2. So there are 36 electrons in that ion. So for the complete chemical symbol, right, you have the rounded number. It always has to be in the upper left-hand corner. So if you see the upper left-hand corner and it's the mass number, that's it. Now in the periodic table, it might say 16.001, right, which is 16. But if it asks you for the atomic number, well, it's 8. If they ask you for the atomic mass, it's the decimal, 16.001. But if they ask you for the mass number, it is the rounded version of this. And then, of course, the charge goes in the upper right-hand corner, right? So you might have something like, hydrogen, 1, 1, and that's it. That means it's an atom, right? It has one proton. The mass number, remember, this is protons plus neutrons. So that means there's no neutrons. I know there's one proton, no neutrons. And because there's no charge in this corner, then the protons and the electrons, they equal each other. Right, in this case, I know that there's 8 protons for oxygen. And because the mass number is protons plus neutrons, then 16 minus 8 is 8. So there's the neutrons, there's 8 also. And then because I need this -2 charge, right, it's protons minus electrons equals -2. So I have 8 minus 10 equals -2, which means there are 10 electrons, right? 8 protons, 8 neutrons, 10 electrons in this ion here of oxygen. So this is what your homework looks like, very similar to the last one, but notice that you have these other values in here. So for the atomic number, get back to that. For the atomic number, right, we need sodium. So we're going to go to our periodic table. We're going to look up sodium. Say, okay, well, sodium is 11. So we know that that means that sodium's atomic number is 11 and the number of protons is 11. And because there's no charge up here, that means that it's an atom, and so the number of electrons are the same. So we had all of those. Now, the atomic mass, that's this 22.990. I'm just going to copy that right from the periodic table. So 22.990. Right? What did we say our number? Geez, I forgot. Sodium is 11. So 11, 22.990. We had 11, 11. Now the mass number is the rounded version of that 22.99. So that is, of course, 23. And to get the number of neutrons, right, it's the mass number minus the protons, or protons plus neutrons equals the mass number, however you want to think of it. So 23 minus 11 is 12, so there's 12 neutrons. Now, if we have a sodium plus 1, it's still 11 and 11, right? It's still sodium, so that doesn't change. The atomic mass doesn't change with a different number of electrons, so that's 22.990. The mass number is still the rounded number 23. The neutrons is still 23 minus 11, so that's still 12. But now, because it has to be protons minus electrons equals plus 1, and you don't have to show this work, of course, but I know that there's 11 protons, and to get a plus 1 charge, there has to be 10 electrons. So there's 10 electrons. And our last one, it's still sodium, so it's still 11 and 11. Notice that there's no charge here, so that's an atom, so the number of electrons equals the number of protons. And then our atomic mass, where it's this rounded number, this 24, it takes precedence over this 22.99. So I'm not going to write that down. It's just 24 and 24. Right? I'm not going off the periodic table because this specifically tells me what the atomic mass is. Now, I have 24, and that equals the number of protons and neutrons. So 24 minus 11, right, gives me 13. So now there's 13 neutrons instead of 12 in these other cases. So that's what you're going to see. You're going to see some of these that are isotopes, where they have different number of neutrons, ions, charged particles, and atoms. And you're going to fill out your chart just like this. Make sure you turn it in when you're done.